Hi APE students, welcome to the Woolly Worm Pre-Lab. Let's go ahead and get started with a little bit of background on the procedure that we're going to use and make sure you're keyed in onto the purpose or the question that we're going to try to answer. So as a class, you will be going outside to do the lab, and it's probably going to be a little chilly, so make sure and bring a jacket to class. You're not outside for very long. It doesn't take us very long to collect the data. The majority of the lab is really analyzing that data. So you are going to be a predator that preys on woolly worms. And one of the key things to remember about our woolly worm population is that this is all the same species. They are a population that is living of those woolly worms that are in a certain area outside the front of the school building. And within that woolly worm population, there's genetic variability. I have everything from worms that are forest green in color. I have brown worms, turquoise, pink, kind of a mottled or multicolored worm. All of the worms are of the same species. There is just color variation within that species. So the question we want to know is, are there some worms that are better adapted to their surroundings than others? Is natural selection occurring, or is the the opportunity for us to prey on a certain color of woolly worm just a chance event? In other words, does each worm have equal opportunity of being caught or selected by a predator? Our statistical null hypothesis is that color will have no effect on the selection of woolly worms, and as a predator, I should have an equal chance of finding any of those different colors of worms. So as we look at our pre-lab question, we have 4 different levels of toxicity in toads that are preyed on by a snake. And you can see that the number of observed in column A, the number of worms that were observed for each toxicity level, that represents how many toads were caught by that snake. Just like we'll have 8 different colors of woolly worms, and our observed will be our class data, how many pink worms were we able to catch, how many red worms, etc. Now the number of expected worms in column B, if there were no selection occurring, and if this were a completely random or chance event, that the snake would have equal chance of getting each different type of toxicity level of toad, then this expected number, 78.5, comes from taking the total number of toads that the snake caught and dividing it by 4. That means that I would have equal chance, or if there were no selection happening, I would expect an equal number of each level of toxicity to be caught by the snake. The rest of the categories are pretty much, the formula is pretty straightforward. The observed minus expected, that number will be negative to start with. But then in the next column, notice that I simply take that value in my calculator and square it. So it goes to a positive value. And then I take that observed minus expected squared and divide it by the expected. Once I have done those calculations for all of the different levels of toxicity, I add those values together to get a total here at the bottom. And that total is my chi-square value. What I do then with that chi-square value is I look at this probability chart, and this is in your packet. The degrees of freedom is 1 less than the number of observations. So since we had 4 different toxicity levels, we had 3 degrees of freedom. And we want to know if that chi-square value is statistically significant or not. So we're going to find our p-value, or our probability value. We can really just notice that this probability chart is divided into values, chi-square values that are statistically non-significant, meaning that I don't really know if the likelihood of catching a different toxicity of toad was by chance, or if it had something to do with the actual toxicity of the toad, versus values that are statistically significant. And we typically accept a p-value of 0.05. That means that I'm 95% confident that my values are statistically significant. So I take the chi-square value, and remember that chi-square value is the total of all of my different toxicity calculations, and I look at my 3 degrees of freedom, and as long as my chi-square value is equal to or greater than 7.82, we say that it is statistically significant. So when we look back at our null hypothesis and we say, does color have no effect? We have to either accept that color has no effect or reject that color has no effect. And our data is statistically significant enough that we are going to reject that color has no effect, because we found, based on our expected levels, that it was statistically significant, and we're saying this was not a chance event, that there was a selection process happening.